Calorimetry deals with the transfer of heat from a hot body to a cold body. Generally, heat travels from a body at a higher temperature to a body at a lower temperature, and it keeps on being transferred as long as both the bodies are not at the same temperature. For example, when hot water is mixed with cold water, heat is transferred from the hot water to the cold water, and it keeps on being transferred as long as the temperatures are not the same. Now, heat lost by hot body equals to heat gained by cold body. Heat lost by hot body equals to heat gained by cold body. Now, what is the formula for heat lost and heat gained? Okay. Heat lost or heat gained is given by the formula m into c into theta. Now, what is m, what is c, and what is theta? M is mass, c is specific heat capacity, and theta is the change in temperature. What is specific heat capacity? All bodies, they absorb heat to a certain limit. For example, water, the specific heat capacity of water is 4.2 joules per gram per degree centigrade. It means that 1 gram of water absorbs 4.2 joules of heat to raise its temperature by 1 degree centigrade. And if it is in kgs, it will be 4,200 joules per kg degree centigrade. That means 1 kg of water absorbs 4,200 joules of heat to raise its temperature by 1 degree centigrade. Different substances on earth have got different specific capacities. There's one more term to understand, that is heat capacity. Heat capacity. Heat capacity means the heat absorbed by the entire body. Supposing a body has a mass of 5 kgs, so the mass into specific heat capacity will give you the heat capacity of the body. So that means when heat is lost by hot body equals to heat gained by cold body is given by the formula m into c into theta equals to m into c into theta. Now, this m is the mass of the hot body, c is the specific heat capacity of the hot body, and theta is the change in temperature, that is initial temperature minus final temperature. And this is the mass of the cold body, this is the specific capacity of the cold body, and theta is the change in temperature of the cold body, that is final temperature minus initial temperature. Remember one thing, the heat lost by the hot body, the theta is always initial temperature minus final temperature. And for cold bodies, theta equals to final temperature minus initial temperature. With this formula, you can find out. Now, there are 6 things, 1, 2, 3, 4, 5, 6. Out of this, 5 will be given, 1 will be missing. And so, you can easily find out whatever you have been asked. Water has one of the highest specific capacities on Earth. Water specific capacity is 4,200 joules per kg per degree centigrade. That means 1 kg of water which absorbs 4,200 joules of energy for every 1 degree rise in temperature. That is a very high specific capacity, and this has got many uses. That is why water is used in a lot of, for example, in car radiators. You cool car radiators with water because it absorbs a lot of heat. On seashores, water acts as a moderator for the climate. And in hot water bottles and hot water bags, people use hot water for their backaches and other type of aches because water absorbs a lot of heat and cools down very slowly. And in grams, it will be 4.2 joules per gram per degree centigrade. Okay. Now let's talk about latent heat. Latent heat means hidden heat, the heat used by the body to change its state. For example, 0 degree centigrade ice will convert to 0 degree centigrade water without any change in temperature. Why does ice turn into water at the same temperature? Because it uses own body heat to convert from its state. Whenever there is a change in state, there is no change in temperature. For example, ice. The latent heat of ice is 336 joules per gram. That means 1 gram of ice uses 336 joules of heat to convert into water. And the formula for conversion is conversion in state. M into L means mass into latent heat of fusion. Whenever, supposing example, if 5 grams of ice to at 0 degree centigrade to 0 degree centigrade water, 5 grams of ice at 0 centigrade to 0 degree centigrade water. That means 5 grams of ice will absorb 336 to convert into water, and there will be no change in temperature. The thermometer will not show you any change. Similarly, when water at 100 degrees centigrade, water at 100 degrees centigrade converts to 100 degrees centigrade steam. There is no change in temperature. In this case, it is latent heat of vaporization. Water converts into steam at 100 degrees centigrade without any change in temperature because it uses its own latent heat to convert. Whenever there is a conversion, whenever there is a change in state, there is no change in temperature. Supposing minus 10 degrees centigrade ice Let me explain it to you with an example. Minus 10 degree centigrade ice to 100 degree centigrade steam. Supposing 5 kgs of minus 10 degree centigrade ice to first step, the minus 10 degree centigrade ice will convert to 0 degree centigrade ice. There is a change in temperature. Since there is a change in temperature, the formula is m into c into theta. Here the mass is the mass of the ice, c is the specific capacity of ice, and theta is the change in temperature, that is minus 10 to 0, that is 10. The second step, 0 degree centigrade ice will convert to 0 degree centigrade water. There is no change in temperature, there is only a change in state. Therefore, the formula is m into L, mass into latent heat of fusion. In the third step, now the water, 0 degree centigrade water will convert to 100 degree centigrade of water. There is a change in temperature. So the formula, since there is a change in temperature, the formula is m into C into theta, where m is the mass of the water, C is the specific capacity of water, and theta is the rise in temperature, that's from 0 to 100. Now the water has reached 100 degrees centigrade. Now this water will convert into steam. 4. 100 degrees centigrade water to 100 degrees centigrade steam. M into L. Why M into L? Because there is no change in temperature. It is just a change of state. So basically, minus 10 degrees centigrade ice to 100 degrees centigrade steam. It occurs in 4 steps. First, minus 10 degrees centigrade ice to 0 degree centigrade ice, that is m into C into theta. Number 2, 0 degree centigrade ice will convert to 0 degree centigrade water, that is m into L. Number 3, 0 degree centigrade water will convert into 100 degree centigrade water, that is m into C into theta. And number 4, 100 degree centigrade water will convert to 100 degree steam, that is m into L. When you add up all the 4, you get the total heat that has been used by the ice to convert into steam. Now let me talk about the sums that involves calorimeters. Calorimeter is an instrument used to find the specific capacity of any substance. A calorimeter is generally made of copper containing water. Now, when you put a hot body into the copper calorimeter containing water, remember one thing, the heat lost by the hot body equals to the heat gained by the cold water plus the heat gained by the copper calorimeter. I'll repeat it once more. Whenever a hot body is immersed into a calorimeter containing water, the heat lost by the hot body equals to the heat absorbed by the cold water plus the heat absorbed by the copper calorimeter. In this case, heat lost by hot body equals to heat gained by calorimeter plus heat gained by water. So, heat lost by hot body is m into C into theta. Heat lost by hot body was m into C into theta equals to heat gained by calorimeter is m into C into theta plus heat gained by water is again m into C into theta. Now, this m is the mass of the hot body, this C is the specific heat capacity of the hot body, and this theta is the change in temperature. That means initial temperature minus final temperature. Since the hot body is losing heat, therefore it is initial temperature minus final temperature. This equals m, this is the heat absorbed by the calorimeter. This m is the mass of the calorimeter, C is the specific heat capacity of the calorimeter. Generally it is made of copper, so the specific capacity of copper into theta. Theta is the change in temperature, that means it is final temperature minus initial temperature plus heat gained by water. Heat gained by water is the m is the mass of the water, C is the specific heat capacity of water, and theta is the change in temperature of the water. That is again final temperature minus initial temperature. In this, there are 9 things, out of which generally one of them will be missing. and you will find the other 8 will be given, and you find the missing number. So a quick recap of what we have done today. Calorimetry is a chapter that deals with the transfer of heat from a body at a higher temperature to a body at a lower temperature. Heat always flows from a body at a higher temperature to a body at a lower temperature, and it keeps on flowing as long as the temperature is not same. Now, the heat absorbed or lost by a body is given by a formula m into c into theta, that is mass into specific capacity into change in temperature. When a body loses heat, it is mass into specific capacity into initial temperature minus final temperature. When a body gains heat, it will be mass into specific capacity into final temperature minus initial temperature. And when there is a change in state, there is no change in temperature, because when there is a change in state, the body uses its own latent heat to change its state. So, for example, 0 degree centigrade ice will convert to 0 degree centigrade water. The formula for this is m into L. L here means latent heat of fusion of ice, which is 336 joules per gram. And when 100 degree centigrade water converts to 100 degree centigrade steam, that is m into L again, where you have to use the specific capacity of the latent heat of fusion of vaporization of water. So remember, when there is a change in state, there is no change in temperature. When there is a change in temperature, the formula is m into c into theta.